Today we are going to learn about the multiplicative inverse or a reciprocal. So these words are synonyms for each other. They mean the same thing. A multiplicative inverse or a reciprocal are the same. And what they mean is they are, let me get my pen. There we go. They are two numbers whose product is 1. So oh, wow, that's really, there it goes. There it goes. It was being slow. So two numbers whose product is 1. So we've been talking about dividing. You might be wondering why we're talking about multiplying now with products, but multiplication and division are partner operations. They are the opposite of one another. And sometimes doing the opposite can help us solve this problem. So let's take a look here at an example using the reciprocal of 3/5. So a reciprocal, or if you invert something, it means you're flipping it. You're doing the exact opposite of it. So the opposite of 3/5, we're just going to flip it upside down, is going to be 5/3. Then we have this word product here, and that's the answer to a multiplication problem. So if we multiply these, 3 times 5 is 15, and 5 times 3 is also 15. 15 divided by 15 is 1. So when we multiplied them, it just came out to 1. It's the same, okay? Now, what does this have to do with division? Sometimes we might get a problem like 7/4, and it might divide by 3/5. I can't do 7 divided by 3 nicely, and I can't do 4 divided by 5 nicely. They don't come out to perfect integers. So what we want to do is we're going to keep 7/4, that's what we have, and we're going to multiply it by the reciprocal, which we know is the same thing, that evens itself out. We do the opposite of divide is multiply. The opposite of 3/5 is 5/3, and that will give us the same answer as that division problem. So let's go ahead and try one out here. So our first step is we want to check if we can just divide. If we can divide, that's going to be easier. But I am noticing that I cannot do 8 divided by 3 perfectly. 3, 6, 9, it does not make a perfect integer. And if one of them doesn't, it doesn't matter if the other do. The numerator and the denominator need to work perfectly if you're just going to divide. So what we're going to do is we're going to use that multiplicative inverse. So those are the real math words, and we're going to use them. The pretend math words that just help us remember what to do is I call it copy dot flop. I've heard some teachers call it keep, flip, change, whichever ones you like. I'm going to call it copy dot flop. So what that means is we're going to copy this first prop number. That is what we have, and it can't change. We have 11/8. Now we're going to put that dot there. The opposite of our divide problem here is to multiply. That dot means multiplication. So we've copied the first problem exactly how it was. We've put a dot, which tells us to multiply the opposite of division. And now we're going to flop this second fraction upside down and use its inverse. So instead of 3/4, now we have 4/3. We are going to talk about step 3 in our next section. So we're actually going to skip our simplify for right now. So now we are going to multiply our numerators. So 8 times 4 is 32, and 11 times 3 is 33. And our last step is to simplify if needed. So those actually can't get any smaller. And it's a regular fraction, it's not improper, so we don't need to divide it out. We have our smaller number as the numerator. So as we're dividing, always check, can I just divide? That will be easier. If you can't, we want to use the multiplicative inverse, and we're going to copy the first one, put a dot for multiplication, and flip the second one upside down. Then we'll talk about simplifying in our next part, and then we multiply the numerators, multiply the denominators.